Hello, welcome to an episode of Beam There Done That. I'm one of the co-hosts, Alan Wyma. I am a software developer and owner of my own Elixir bespoke custom software studio in Hong Kong. And today I have with me, as usual, Francesco Cesarini.
Hi everyone, I'm Francesco, ex-Erlang Solutions, entrepreneur, angel investor, lecturer at Oxford University, offered podcast and podcast co-host, and I guess, jack of all trades. Let's get to the show. On the show, we keep circling around one question, where should your state live? Chris McCord gave us an answer, with durable servers, keep it on the server and move it across the planet. Adi showed us the framework underneath it all, explaining where and how LiveView keeps your state and logic on the server and streams the changes down the socket through the browser. And all of this really sounds great until the laws of physics hit you. We often got that from Joe Armstrong, that data can't travel faster than the speed of light. And well, we've got a guest on the show today, and he's made the opposite bet to LiveView. Write your code in Elixir and run it in the browser. He used the local first approach. This is an approach some of you listeners might have heard, which we covered with Brooklyn's Zelenka and Robert Virding a few episodes back. There's no JavaScript, there's no round trip, there's no inconsistent data, and that's Hologram for you. It's 6 years of work. The last 3 years have been full time. Bart Blast, welcome on the show. Tell us about yourself and tell us what Hologram is.
Yeah, thanks, guys. Great to be here. I'm Bart, the creator of Hologram. I'm Polish, based in Warsaw. I found Elixir around 2017, I guess, and started working on Hologram in July 2020. So it's been almost 6 years, and the last 3 were full-time. So Hologram is a full-stack web framework that runs your Elixir in the browser, and its goal is to rebuild the Elixir runtime with all the Beam guarantees in JS, so that the whole app is basically pure Elixir and you don't have to write JS yourself. So the way I put it usually is it's like LiveView, but running directly in the browser. So, it feels like a native app. And also it's heading somewhere bigger than the browser tab. So the local first layer is next, then it's mobile and desktop. So eventually and hopefully it becomes a cross-platform development from a single Elixir code base.
Bart, on paper, this sounds, I think, almost stubborn. We'll coin a new saying, Joe Armstrong stubborn. The browser speaks JavaScript, and you decided to make it speak Elixir instead. Most people will call that swimming upstream. What made sure you wanted to swim upstream? And what made you believe that it was worth it, rather than just reaching out for the tools, the browser already wants you to use?
Yeah, so I'm happy to own the stubborn, but from the inside, it feels more like a conviction. And the honest reason isn't some grand thesis or something like that. It's just plain frustration. So Elixir is a pleasure to write, but when you go to the front end, it basically means you're leaving it for JS. So you lose all the Elixir goodies like immutability, pattern matching, and all the Beam guarantees, and you end up fighting problems that the Beam doesn't even have in the first place. So I kind of feel that we've all normalized it, and not because it's fine, but because we stopped questioning it. So the browser, it owns the tools that in specific circumstances were the answer, but never for me, because you still need to leave Elixir behind. And the motivation is embarrassingly simple. So it's the line I keep coming back to, and it's just that I want to basically write Elixir all day, and that's it.
My antiquated view, from the Erlang world is that front-end and back-end developers solve very, very different problems. And as such, for me, it has always made sense to have a very, very clear separation between the front end and the back end. And, if that separation was actually a programming language, all the better. You don't seem to agree.
No, I actually don't disagree with this principle at all.
So you're a
And
back-end
this is
developer as well, right?
yes, exactly. I'm
So
coming
that's
from a background, so I definitely don't disagree with this principle. And there is this part I want to be careful about. So Hologram doesn't merge your front end and back end into some kind of a big big blob of code, right? So in Hologram, the front end layer is the component layer in the browser, and it has its own state, and the backend is only for what needs the server. So something like database access, auth, and the calls to the server are stateless. So it's still decoupled. There's still this separation of concerns. It just happens there is a one shared language, right? So what I'm removing isn't the boundary, it's just the language tags on crossing this boundary. So, when I think about it, right, just this little bit of JS that you somehow add, it never comes alone. And it usually, actually, it always brings friends. So this usually means a front-end framework, some build step, some separate backend to connect to, the serialization over the wire, this kind of stuff, double validation, and you've got these two mental models that you need to keep in your head all the time. So that's the accidental complexity I'm after. And actually there is a nice precedent because like for the JS devs, when Node.js let them use JS Node in the backend, so it's exactly the same instinct, just opposite direction. And I already know this language, so why not use it everywhere, right?
We already have something like Phoenix Live View, which for a lot of people really makes sense, right? It kind of copies the idea of React, right? Kind of a top down state where things are just get pushed to the front end, and we have a simple, very thin amount of JavaScript that just kind of merges everything together. Why is it that we need to kind of break this principle that's kind of been working for us for some time as Elixir developers?
Yeah, so the problem is that for server rendered frameworks, we get a lot of latency. And this is something I need to untangle for our viewers, because sometimes people complain these things. So usually, server render frameworks in this round trip between the client and the server. So fast internet is what we mean usually when we say fast internet is the bandwidth, right? So it's the megabits, and this is improving every year. But when you use server render frameworks, they all feel sluggish because the interactions need to go through the server, and this is latency, so the round trip, right? And latency has basically a floor you can't bypass, and it's physics, ultimately the speed of light to your server. So each round trips per interaction is basically a hard ceiling. So bandwidth can't move it, right? And additionally, when you use server rendered frameworks like LiveView, Hotwire, and this kind of frameworks, the server state is fragile as well. So deploy may drop sessions, crash same, even weak signal can freeze the UI. So imagine you are in a train and you've got nice 5G connection, and it's great until the train hits a tunnel, right, and everything stops. So when you run it in the client, none of that touches you, and the interactions feel basically instant. So that's the ceiling I care about, and is the thing you genuinely can't out engineer on the server side.
But I mean, we also have something like a hook, right? I believe Jose has a very good video where he was showing how, I believe it was Anthropic's website, like how you can have this kind of, what do you call that? I think there's something like I forgot what the word is. It's like you already know this is going to happen, so I can already on the client side hide this element or something like that. I mean, why can't we just rely on that rather than use your framework?
Yeah, so the JS escape patches in LiveView, they do help, but there is this cause and the cause is exactly the JavaScript we were trying to avoid in the first place. So this is still the two language problem, because eventually hooks, custom interactions, double validation, and when you need to implement those, you're back in the JS world. So just to be clear, not a knock on the Phoenix Live team, because the problem is structural, right? So the reason is the state on the server means that the client-only interactions basically can be clean without imperative code. And however good the abstraction is, it eventually leaks in some way. So an example I usually give for this is, like, imagine, for example, like a smooth real-time drawing animation, like, so like something like drag and draw on an SVG. So if we wanted to implement this kind of thing with the live view, every mouse move would have to go through the server, then back, be reapplied. And as you can see, this means a lot of latency, right? So in Hologram, that handler just runs in the browser, and it is because it's Elixir compiled to JavaScript, we don't need any hooks or any round trip.
There's a second cost you have beyond latency, and that's keeping the front end state on the server consistent. What is the actual cost behind this? What are the hidden costs?
Yeah, so there are definitely costs, and it all traces back to this one choice: keeping the UI state on the server, the way LiveView does, instead of the browser like Hologram. So some of the cost is just resources. So you need a process, a connection state per user. So this means consumption of memory, CPU, bandwidth, or diff payload. But the subtler cost is the consistency, right? And that's your actual question, I guess. Having UI state now in two places means you've got the model on the server and the live DOM in the browser, right? They need to stay in sync over the network. So you basically turned a purely local thing, like your user screen, into a distributed systems problem. So you will have sync, some races, and you need to reconcile your data and this kind of stuff. So that's one problem, one cost. And another is that, like, the connection can drop, a deploy.
No, go ahead.
Deploy can,
sorry.
Yeah, so a connection can drop, a deploy can wipe your state on the server, and basically it vanishes on the server. So when you move the state to the browser next to the DOM, basically the whole class of problems basically collapses. So you've got one copy of the state, there's nothing to sync and nothing to lose. So it's a local problem again, which is really what it always should have been, in my opinion.
Can you share a little bit more about the strategies on keeping this data synchronized, where possible, assuming there is no failure? How have you actually optimized it?
So we don't need to synchronize at all because you keep the state on the client. And when you need to reach the server, you basically use commands, which are kind of a remote procedure call, and you communicate in a request response cycle. So you keep all the UI state, which is usually ephemeral, on the server, and you don't need to synchronize anything at all.
So the thing is, the browser basically only speaks two languages in theory, right? Let's just, it is a language, right? HTML and JavaScript, right? So you've basically chosen JavaScript to transpile the JavaScript instead of WASM, right? I mean, why is that? Like, to me, I understand that WASM kind of is a lot faster in terms of running raw code, raw speed, right? So can you talk a little bit more about that?
Yeah, so yeah, that's true. People usually expect WASM to be the obvious answer in this kind of things like isomorphic code, which Hologram is. And for UI, for UI work specifically, it really isn't, in my opinion. So the biggest reason is the bundle size. If we go the WASM route, we basically need to compile the whole Erlang virtual machine to WASM, and usually also ship your Beam files to the browser. And usually it means like 5 megabytes or more of compressed bundle size, and before even you've done anything. So 5 megabytes at least. And Hologram ships none of that because the whole runtime with the framework is just about 89 kilobytes compressed, so it's over 50 times smaller. And the second thing is, actually there are a few more things. The second one is that the DOM lives in the JS world, so WASM can touch directly, and there is some tags for crossing this bridge with serialization on every interaction between JS and WASM world. Not much, but it's still there. Plus, being a plain JS solution, you can reuse the browser built-ins, some kind of piggyback on the browser, as I usually say it. And you in the browser, you've got something like Unicode, compression, crypto, all other APIs, and you can use it somehow under the hood in Hologram. You don't need to compile the Beam part to it for it. Another thing is you get readable output because Hologram compiles Elixir to JS. So WASM shines for heavy compute, but UI logic isn't the bottleneck here. So for web apps, I think JavaScript is the better target here.
I'd like to understand more about if I were to start to use Hologram, how do I structure the code? Like in terms of what am I dealing with, right? Do we have components? How do I kind of build up my mental model so that way I can translate business requirements to an actual working piece of software using Hologram?
Yeah, so we've got a few building blocks. So basically 2 UI blocks and 2 kinds of behavior. So components are the reusable UI blocks, and that they bundle logic, view, state, and they take props as their parameters. There are also pages, which are specialized component, and they are bound to a route, and they take URL parameters. They need to define a layout. So a page is some kind of root of the component tree, and pages also render on the server first, and then they come alive on the client. We also have views. So these are holo templates, a specialized holo sigil or .holo files. So you can also co-locate the templates. And the templates, the holo syntax is basically HTML mixed with Elixir. You can use some event bindings, like with a specialized syntax like $click. You've got control flow, like if, comprehensions, and these are basically pure Elixir structures. And what's nice is that templates compile to data structures. They are not strings, so it lets the Hologram runtime to div the components efficiently. And for behavior, you've got actions, which are client-side. They are synchronous. They can touch state and they re-render the components. There are also commands, which are server-side, asynchronous. They can fail, and they go to the server, and this way they can reach the database, sessions, and cookies. And what is nice about these behaviors, they form a kind of a feedback loop, right? So an action can fire a command, and a command can fire an action back. And what's interesting is I borrowed the naming from Elm commands and Redux actions. So action suggests immediacy, and command implies a remote call. So that also tells you exactly which code ends up on the client side.
There's a physical limit on server rendering. There's a real cost to holding a UI state on the server. And your answer is run Elixir in the browser and keep the state next to the DOM, And that sets up the question I actually want to spend our time on. How does it work? Where does it beat live view? And where, doesn't it? And most important, where is it all heading? We had Chris McCord on the show a while back, so the creator of Phoenix, and the whole episode was durable servers. His work on keeping server-side state alive, globally addressing, making sure that the state was globally addressable. It was about surviving crashes, picking up exactly where it left off after a restart, and even moving the state across the planet. Yeah, and that's one answer to the hardest question in interactive web apps. Where does state live, and how does it survive? And well, Chris McCord's answer is to make the server state durable. Yours is the opposite. Move it off the server onto a client next to the DOM. So make the case to someone who just heard that episode. Why is the client the right home for the state? And where do you give it up by putting it there?
Yeah, so the simplest way to put it is that most UI state is ephemeral by nature, right? So a menu being open, what you've hovered, something like a half type form, this kind of stuff. So none of this is a permanent record. And its natural home is a browser by nature. So next to the DOM, exactly where it needs to be used. So actually durable servers are genuinely valuable for state that belongs on the server, like long running workflows, surviving crashes, or from what I understand, you can even move it across the planet, right? So yeah, but UI state never needed to be there on the server. Using durable servers to keep that alive is basically solving a problem you created by putting it on the server, in my opinion. So Hologram takes the other fork, keep the ephemeral UI state on the client, and this way there's nothing to lose. You don't give up what matters there, because durable record still stays in the database, and the server still owns the auth and security. So I'm generally not knocking durable servers; they have their place. I just don't think UI state is one of them.
I mean, there has to be some cases where state being on the live view or live view way could be actually be better than hologram. Could you give us some use cases where that could be?
Yeah, so the cleanest case where live genuinely wins is, for example, keeping UI logic private. Something like anti-cheat in a game, say, or some proprietary ranking, or something like a pricing algorithm, this kind of stuff, when you need to keep the logic private. So Hologram runs your code in the browser, so it's public by nature, and this is similar to an SP in that regard. And LiveView keeps your logic server side, and it ships only HTML. And another pool I can think about is data-heavy apps. So when your working set is on the server, and the interactions need to hit it anyway. So for this case, the server rendered is linear today. But the boundary is moving. My local first auto-sync layer, I hope we'll talk about later, is going to close this gap soon. And honestly, none of these things are something that Hologram can do, because it does SSR, and sensitive logic can live on a server-side command. So you can send a command, execute some logic on the server side, and return the result to the client. So it's still covered. It's just Hologram is the superset of LiveView in some way. So LiveView is just cleaner for those cases today. And for the huge space of rich interactive UIs, I think client side is the better architecture here. So that's where I want Hologram to be the default in the near future. And another gap that is left is maturity. So this one is obvious, but it closes with time, of course.
So we did an episode with Adi Iyengar on building your own web framework. His book basically demystifies, Phoenix under the hood, talks about, all the magic behind it and how it all works and how you can basically replicate it on your own. Hologram feels like that instinct taken to its limit, not just rebuilding the framework, but compiling the language into the browser. I mean, how deep did you actually have to go? Is it just framework deep or compiler and runtime deep? Like, how deep did you have to get into the Beam and Elixir and everything else involved?
Oh yeah, so definitely compiler and runtime deep. There is no shortcut for that. So Hologram started as a transpiler years ago, and now it's a full compiler under the hood, and it incrementally rebuilds the Elixir runtime, with all the guarantees and all the pieces like OTP, ERTS, and all implemented in JS. And mechanically, Hologram pulls the expanded AST from the compiled Beam files, then it normalizes it, lowers it to an IR, intermediate representation, and this IR is supposed to bridge Elixir to JS, and then this IR is encoded to JS runtime, so it's not one-on-one translation. And the real point is rebuilds the runtime, right? So values are boxed to keep their type. So for example, Elixir integer 42 becomes something like an object in JS with fields type integer value 42n, so a big int. So we've got arbitrary precision and this kind of things to make it consistent. The control flow is mirrored, so there is a real pattern matching engine which tries clauses, binds vars, evaluate guards, and so on. So just like the beam. So for example, tuple OK value just stays a tuple on runtime. It's still boxed, and it's data, not some translated control flow. And when you think at it from high above, it's like, and almost none of that shows. Actually, none of that shows up when you're using it. What you write is tiny next to everything that the runtime is doing underneath. You just write pure Elixir in Hologram.
The clever part in all of this is that you don't ship the whole app to the browser. How do you decide what actually gets shipped?
Right, yeah. It builds a call graph over your whole project. So all your dependencies included, including the Elixir standard library, treating your actions and templates in the components and pages as the entry points. And it traces everything reachable from those entry points. And then it tree shakes the rest. So, each page ships only the code it actually needs. And as I mentioned, the Elixir standard library is just more depth as far as the graph as far as the graph is concerned, and it's traced the same way. So there is no separate standard lib graph. And at the very bottom, Elixir standard library functions call down into Erlang functions. So the Hologram compiler can handle those because they are native and they are implemented in the VM. So we need to hand port them to JS, and only the ones that you actually reach through the call graph get bundled. There is also a big part of why the Hologram runtime stays 89 kilobytes compressed because of this call graph analysis. So we don't need to ship the whole word, basically, just the things that are reachable through the call graph. It's also why the action command naming matters, because the call graph traces from actions, and everything is reachable. And everything that is reachable from the action becomes public. So it becomes a client-side code. So the distinction keeps an honest mental model of what ends up in the browser.
I mean, that sounds quite tricky. Like, what's the hardest part to get that correct, and what do you think that people actually underestimate about that?
Yeah, so the hardest part by far is basically faithfully reproducing Elixir semantics in JavaScript, so your code can behave identically in both places. So that's the whole isomorphic promise, right? And that's the multi-year grind, basically. So what's hard is the pattern matching, immutability, guards, bit strings, so all the runtime internals, and to get them right and match the OTP behavior, even down to exact error formats, basically. And a huge piece is porting Erlang's built-in functions to JS by hand. And it works in such a way that each one is re-implemented in JS and verified against the real OTP behavior with strict consistency tests. So if there is some behavior change, for example, in new OTP versions, these are caught in the tests. And that was actually a real community effort through the Elixir JS porting initiative some time ago. And big reason phase one got finished so fast, because about 50 contributors help with porting those functions. And the tricky corners are everywhere. The browser doesn't give you the same primitives Elixir assumes, so you need to recreate the behavior carefully. And this is also why JS not WASM paid off, that we talked about a little earlier, because you get readable output, so it's debuggable, and you can reuse the browser's own functions. You don't have to compile everything. So it's gargantuan scope, and I won't pretend otherwise.
Now, you're not the only person who's doing something similar in this realm, right? So Haley Thompson's, I think it's called Luster Framework in Gleam, is doing something very similar. How does Hologram and Luster, besides different language on the beam, kind of compare with each other?
So real respect for Haley for the whole corner of the ecosystem, and honestly, I admire Luster from a distance. I won't pretend I know its internals deeply. We are basically cousins. We both bring a Beam language to the browser. We both compile to JS. We both put logic on the client. And from what I understand, we are both Elm inspired because my state model aus Elm too, and I think the meaningful difference is which language you're already in. So Lasser is built on Gleam, great language by the way, and is a natural fit for Gleam developers. And on the other hand, Hologram is for Elixir dev, so it runs the Elixir you write in the browser, syntax, semantics, macro protocols, all of the Elixir syntax. So there is no new language to learn if you want to run it in the browser. And a deeper technical contrast, as far as I understand it, because as I said, I'm not deep into Lustre or Gleam, is that in Gleam you've got a minimal prelude, and from what I understand, Gleam treats the two targets as basically different, so it doesn't replicate Beam processes, for example. And Hologram is rebuilding the Erlang runtime for full parity eventually. So we will have heavier runtime, but the same Elixir is able to run identically on the server and client. So the payoff is the same Elixir code running the same on the server and in the browser. Yeah.
I mean, it almost sounds like you're both targeting to huge ecosystems and different types of programmers. Do you consider the two platforms as competing with each other or coexisting? And a follow-up question to that is, what can you learn from each other?
Yeah, so I don't think we're competing, definitely not. I think it's two bets on the same pie. And if you've got more opinionated takes in the ecosystem, the developers have more choices. And and this way the diversity makes the whole Beam ecosystem stronger, right? So what we can learn from Lastre is actually not technical, and what I admire the most is the adoption story and the community. So it's very low risk to try. It's easy to adopt gradually, and Haley and the Gleam Forks created a very warm and welcoming community with great dogs. And it matters as much as any feature, as far as I'm concerned, and that's where I take notes. And going the other way, and I bet I'd hope it is interesting for the Gleam team and for Lastre, is the goal of full parity in Hologram with the Elixir. So rebuilding enough of the Beam that the same Elixir runs identically on both sides, and it's currently a different edge from theirs. So either way, the real competition isn't each other. I think is the churn of the mainstream JavaScript ecosystem.
That's a really good answer. Thank you for that. Now, we're very much kind of advocates of the right tool for the job rather than the tool at hand. When would you tell someone not to use Hologram?
The honest headline is that it's still a young framework. So wait project maturity, the tooling, this kind of stuff, and the size of the team behind it, but it's a young library pain, not a niche language pain, because Elixir itself is already battle tested. And the new part is Hologram. And of course, the gap closes over time, of course, right? So there's also always the JS escape hatch. So if anything, Hologram can do it. You just drop down and write it yourself in JS. It's not much. And this way you're never actually stuck. So current rough edges are, for example, which are temporary by the way, but still real, is that there is still no 100% Elixir standard library coverage. Another thing is that the bundles are a little bigger than they'll eventually be. So yeah, that's another thing. There's also the tooling problem. So recently I shipped VS Code extension, which has nice hollow syntax highlighting, but Vim and other editors are still coming. Something like Holo DevTools, but actually the Hologram community also already started working on something like that. Yeah, so the fit for live view is something like heavily server driven with no client interactivity, and this kind of apps will be happier on live view today. But none of this is a reason to look away, to be honest. And yeah, just read the label stuff, right?
The web is not the only stop on the train, right? You're going to be taking this to beyond the browser, right? What's in it for the timeline? Where are you looking to go?
Yeah, so beyond the browser tab really starts there really starts something that is what I'm most excited about, and is the local first layer. Autosync data store that will be running on the client. So imagine a client-side store that syncs with the server using some declarative rules that you define. And this way, the app will basically feel instant because you will have a subset of your data stored on the client. And this way, the app will be able to work offline. And when it's done, it's the foundation for something more. Once your data works offline, mobile and desktop become real. So that's the second horizon, multi-platform. So one Elixir code base, meaning web, then mobile, then desktop through web views in native shells running everywhere. So write once, run everywhere basically. The second horizon is a little further out, but it's also exciting, is porting of the process model to the browser. So the way I imagine is that a pool of web workers running as schedulers. So basically playing spawn, send, and receive with all the OTP work will be able to run client side. And when you think about it, it's generally a unique idea compared to other ecosystems because nobody is bringing the actor model to the browser by construction, and it's actually part way in some ways because currently hologram the components are the actors, actions are the messages, and basically immutability in the runtime makes it all hold. And the macro bet for hologram is that the web platform keeps getting more capable. So I mean things like web GPU, file system, hardware access, faster engines, and this kind of stuff. A few things will eventually enable more native stuff become web possible. So to be honest, I'm not 100% sure every piece will work perfectly, of course, but the ideas are reasonable and worth trying.
All of this points to local first, offline capable apps written entirely in Elixir running in the browser. That's a different type of application than most of the Elixir world today. Do you agree? Do
Yeah,
you
I agree.
require so? And I'm thinking it's just a very different mindset to when you're actually going in and coding these types of applications.
Yeah, and it's a very new thing for like the whole web ecosystem, not only Elixir, because it's basic new horizon, but it's exactly where it's all heading in hologram. So I need to, give a quick definition for our viewers because the local first term gets a little muddy sometimes. So what I mean by local first is that the UI isn't blocked by the network. So the reads are instant, and from a local store, the writes are optimistic, and the app can keep working when it's online, offline. So server still matters in this kind of setup because you still need auth, conflict resolution, some shared state, and the server still stays the source of truth. And hologram doesn't want to force all the state onto the client, just only the stuff that it needs. And it kind of is a natural fit for a hologram because most stacks bolt offline onto a server dependent architecture in some ways, which is often basically painful. And hologram already starts client side, so logic and state already live there. So offline first becomes the natural grain of the framework. And what I'm building is a declarative autosync local store. So declare the sync rules, and framework handles local versus remote kind of automatically, right? So the bar is to make it completely invisible. So subscribe to the state, no events, and never think about local versus remote. And as you notice, it's a new territory, and the sync layer is genuinely hard for everyone. It's a hard problem. There has been a lot of research for this, but it's the theme of my 2026 talks. And that's where the project's been pointed since ElixirConf 2025, actually.
We need to be honest about what it takes to build something like this. I mean, 6 years, the last three were full time, and that's a real commitment. And, open source at this level, isn't free. What's the sustainability picture for a project like Hologram? And how are you handling, security vulnerabilities, and what does support actually make possible?
Yeah, so honestly, the full-time part came at a real cost for me, actually. First 2 years that I worked full-time on it, I funded it myself out of my own savings just to work full-time on Hologram. But, it's not sustainable long term. So the second half of the last year, I also did some contract work alongside it, but, it meant basically 60-hour weeks. And I ended up at real crossroads. So because I was always tired and this kind of stuff, and nobody deserves a maintainer that is stretched that thin. And what's changed at the beginning of this year is the sponsorship, and actually a combination of sponsorship. So Curiosum became the main sponsor. I joined their team, and I'm able to work full time on Hologram. And also, Erlang Ecosystem Foundation awarded a stipend for Hologram for specific milestones. There are also individual GitHub sponsors that help. So all these three together create some sustainable footing. So I don't have to fund the project out of my own pocket. And what the support buys is the focus, basically, right? So I can work the whole week on it, and this is the reason the local first is happening now and not like in 5 years or so. And also I've got an honest ask. Individual sponsors are a real part of keeping this work sustainable, and quite a lot drifted once the big ones came on. So it still genuinely matters, and if Hologram matters to you or your org, sponsoring it on GitHub sponsors is what keeps the momentum going.
For someone who's only ever built UIs with the server rendered way, what's the one idea you want them to walk away with after having listened to this podcast?
The one idea is that you don't have to choose between everything on the server and driving and drowning in JavaScript, because it's a false binary in my opinion. Because there is a third option, your own Elixir running in the browser. If your logic is just Elixir, it can run whenever it makes sense, server or client. So the round trip stops being attacks on every interaction as in the server rendered frameworks. And that's the whole thing. So same language, end to end. And honestly, I think a lot of people here secretly want that too. So stop handing Elixir back the moment the browser shows up and come to Hologram.
I mean, the project sounds pretty interesting. I mean, how can people follow what's going on with Hologram and what you're working on too?
Yeah, so the easiest place to start is the website, hologram.page, and the docs it has. There are also some live demos like a physics simulation with a bouncing ball, SVG drawing, so you can get the client feel and see how it's working. You can follow along because I'm building in public on LinkedIn, on X, at Bart_Blast, Blue Sky, if that's your platform. There is also the newsletter, monthly newsletter at hologram.page/newsletter. There is also community. Currently, the Discord is the main hub, is the business one. That's where I'm daily, so come check it out. There's also the Hologram tag on the Elixir forum. So if you prefer some long forms of communication, some posts and this kind of stuff, check this out. There's also a Hologram channel on the Elixir Slack. But to be honest, for real-time chat, this Discord is the place to be. It's a little more busy. Code's open on the GitHub, so Bart Blast /Hologram if you want to look under the hood or back it up through GitHub sponsors. Either way, come say hi and ask me anything.
Thank you so much for that. So yeah, we're drawing to an end, and we've circled the same questions in 3 episodes now. Where should your state live? Chris McCord, made the server durable and moved it across the planet. We've had Adi explain how to build a web framework, and showed how state is kept in live view. Brooklyn Zelenka and Robert Virding, gave us a local first approach, synchronizing with the backend and choosing what data you copy and what data you share and with whom. And today, the fourth episode, Bart moved it the other way, moving it from onto the client next to the DOM in pure Elixir. So these are 3 answers, 1 question, and really this is what the show's about. Bart, thank you so much for being on the show. And for our listeners, if you're new here, go back and listen to the episodes I've just mentioned, because they're the other half of this conversation. And everyone, don't forget to subscribe. Until this time, and just for the record, this episode was recorded June 18th, 2026.